The Cedarville Solar Boat Team is excited to compete in the Solar Splash competition. Our team consists of 6 senior mechanical engineers led by Dr. Timothy Dewhurst and Dr. Gerald Brown. We have focused on testing and improving our motor's performance, designing and manufacturing a new propeller for the sprint race, and adding more electronic systems for data acquisition. With these improvements, our goal is for our boat to be faster and more efficient than ever. We were able to test our motors using our dynamometer. We recently acquired a 3,000-pound battery to aid in the number of high current tests we are able to do on a single charge. The battery power goes through this test board and into our motor controller. The test board allows us to measure the voltage and current from the battery. Using the control panel, we can control the power going from the motor controller into the motor. We can simulate a load on the motor with our dynamometer and collect data for our tests. This testing allows us to find the most efficient operating point for our motor, as well as the amount of torque the motor can produce at different speeds. A goal the team had this year was to improve the performance of our boat during the sprint race. To accomplish this goal, we designed, manufactured, and tested a new sprint propeller. We used MATLAB and OpenProp to design our propeller. We chose a design that will allow our boat to reach speeds over 30 miles per hour and generate more thrust compared to previous years. We took this design and manufactured the propeller on our CNC mill. We have been testing our boat with this new propeller to maximize its performance during the sprint race. On our boat, we have several sensors that communicate on a CAN bus. These measure data such as the voltage of the batteries, the current being drawn, the rotational speed of the motor, and the speed of the boat. Some of the sensors output their readings directly to the CAN bus, while others are read by custom CAN adapters that our team has previously designed. A tablet has a graphical user interface which displays the data to the driver for strategic use in competition. This year, we updated the program to include a new way to record data that would be more robust and customizable. In addition, we added a Raspberry Pi computer as another system for logging data for redundancy. Being able to collect data will allow us to better see where improvements need to be made for each race. Along with these main areas of work, we have also improved our boat by adjusting our drivetrain. We lowered the drivetrain farther into the water and have added the ability to change the direction of the drivetrain from a rear-facing propeller to a forward-facing propeller. This design helps us maximize our performance in both the endurance and sprint competitions. Some items on our boat have not changed this year. We're using the same solar panel design, which has worked well for many years. The design consists of 3 Solbian SP125 solar panels and 1 Solbian SP100 panel placed behind the driver. We are also using the same batteries as previous years. We're using 3 Genesis 42 EPs for the endurance configuration and 9 Genesis 13 EPs for the sprint configuration. We have been working hard to get our boat ready for Solar Splash and are excited to compete in the competition.